Unlike the other programming languages that we've talked about in here, Java, which is a modern object-oriented language, was almost an accident. In the early 1991, Sun Microsystems created a team of top-notch software developers and gave them just pretty much free reign to do whatever they want. They just told them, create something, have fun with it. So what this team was originally trying to do is come up with a system and a language that would allow electronic devices to be able to communicate with each other over the network. So we're talking about consumer electronics, so televisions, VCRs, stereo systems, CD players, and so forth, so that we can actually communicate with each other. So they came up with a language for that. They came up with an interface. They came up with an operating system, the hardware architecture for a handheld remote control device. So it would allow this communication to go on. Now that was great and all. And then during this time, this is when the World Wide Web came out. So remember we were talking before, around 1993 or so is when the first web browser came out, which was Mosaic. So once Sun found out about this, they decided to just kind of change direction. So instead of going for all this communication among different devices, they decided to shift their focus into a platform independent approach. So coming up with a language that was independent of any platform, something that was reliable, secure. So all the stuff they have been working on before did pay off because they did come up with a web browser. And the programming language that was used in their original design helped with this as well. This was originally called Oak, and the language was actually used in their first web browser. Now, eventually, they made some changes to it. So it was later renamed to Java, and this was the language that was used for that web browser. And the browser was released in 1995, and the first version of the Java programming language itself was released in 1996. And then after that, well, Java just gained a market share among programming languages at quite a phenomenal rate. Now, there were two different types of Java programs that were available. The first type were the applications, and these were the standalone programs that would run on a machine. They were just the normal types of programs that we would see in any of the other languages that we've talked about. But Java's development went hand in hand with the development of web browsers. So the second type was actually called an applet. So these were very small applications. They were programs that were designed to run from web pages. So the idea with this is that these applets were actually embedded in web pages, and then they would be connected to central servers. So whenever a user would view a web page with a Java-enabled browser, the applet code would be temporarily transferred to a user's system and then interpreted and executed by the browser itself. So these were just simply programs that ran in web browsers that supported Java. Now, this was pretty popular in the late 90s and even the early 2000s, but applets were no longer supported by browsers because it was very easy to inject code into these applets and cause security breaches on people's computers. It was very easy to hack into their machines, send viruses, and so forth. So most browsers nowadays don't even allow you to even execute applets. What made Java popular was a lot of the features that it provided compared to other programming languages. For one, it was an object-oriented language that was based on C++. So we had a lot of the things where we can create classes and objects, and we can classify an object with the data that would contain and some of the operations that it could perform. So it was really popular with just that alone. It was also very easy to implement GUIs with Java. Most of the applications up to this point were text-based, so there really wasn't icons or anywhere to click on stuff. But Java made it really easy to create different types of windows and boxes that have buttons to click on and things to type in. So it was really popular for its way to implement GUIs. And it also avoided some of the issues that C and C++ had. So like, for example, being able to access invalid memory addresses. This was an issue in both C and C++ because we can directly modify memory addresses, but if we try to modify an address that we weren't allocated to, then the program would just simply crash. Whereas in Java, this was not an issue. It would just cause a runtime error if we're not allowed to do that without causing any issues with the system. And one of the main features with Java was its portability. So we talked a little bit about this, but the idea with it is that we wanted Java to be a machine-independent language, and that's what they were able to do, this team that we talked about before. So the way Java works is it would compile into object code like other languages. You would compile it once, and then we got our object code that's in either assembly or a machine language, and then it would just go from there. But with Java, we actually compile the source code just once into a low-level code, which is called bytecode. And then this bytecode would be distributed to the other users, or it would be used on a particular machine. And the bytecode itself is not a language of any real machine, but it can be translated into any specific machine language. So what we would have here is the source code itself would be machine independent. And then you would compile it like you normally would into bytecode, and then this bytecode would be specific for a particular machine. So the Java virtual machine would interpret that bytecode and convert it into the machine instructions and then execute on a particular machine. So I mean, as long as you had a Java virtual machine for the type of system that you want to run Java on, and I will mention that the Java virtual machine is a very small piece of software. It's no hindrance at all. But as long as you had that, you can run Java on that particular machine. And so what's nice about this is you can write a Java program and you can have it run on any machine that you wanted, just as long as it had the virtual machine. The Python programming language was originally created in the early 1990s by Guido van Rossum in the Netherlands. Its development is now overseen by the Python Software Foundation, but van Rossum still has a final say in any of the official features of the language. Now, what makes Python different from other languages is that it is an open source language. So what this means is the source code is freely available and can be used, distributed, or modified by anyone. People claim that by having a community of people interested in using and improving the language, it's actually led to a better language than whatever would have resulted from standardized or proprietary code. Python is also an interpreted language, which means it's translated from source to object code at every execution. Now, Python was originally used for system administration tasks, such as a web interface language. But with the development of an extensive library for supporting code, Python has become a very powerful language for more general use. A lot of companies like Google are using it just because of all the features that are associated with it. I mean, that this main distinguishing feature among all the procedural family of languages is how easy it is to use the language. The syntax rules for Python are a lot more relaxed compared to other programming languages. So it's more relaxed and more intuitive. So it makes it very easy to develop programs rapidly. In fact, some problems can be solved with just a handful of lines of code in Python, whereas it would take a ton of lines in some of these other procedural languages to do the exact same thing. But the thing about it is, and the one downside with Python, is that it puts a lot of responsibility in the careful usage on the programmer rather than the compiler or the interpreter. We'll now take a look at the C# programming language. This was developed in June 2000 by Microsoft. The language was actually a successor to C++ in spirit, but it is a totally new language, which means it doesn't have any of the backwards compatibility issues that C++ had with C. So I mean, you can't put C++ code in C#. It's just not going to work. It's not backwards compatible. Now, C# was designed to make improvements over C++ in safe usage, and it also shares many features with Java in terms of security and reliability. So one such example is, like Java, C# actually has automatic garbage collection. And what that means is that we can reclaim memory that's no longer needed by the program. This was not a feature that was available in C++. Whenever you allocated memory for something, you had to make sure you release that memory. Otherwise, if you just kept allocating more and more memory, you would run out of memory. So with C#, it actually allows us to automatically deallocate that memory when it recognizes that it's no longer needed. Now, it's impossible to discuss C# without discussing the Microsoft .NET framework. Essentially, this is a giant collection of tools for software development, and it supports C# and other programming languages. It was designed so that traditional text-based applications, GUI applications, and web-based programs can all be built with equal ease. So for example, the .NET framework provided a whole library of classes for building GUIs with menus, buttons, text boxes, and so forth. And it is the .NET framework that actually handles the garbage collection of a C# program or for any other languages that use the .NET platform. All .NET programs in whatever language are compiled into Microsoft Intermediate Language Code, or MSIL code. So just like the Java bytecode, MSIL code is not tied to any particular platform. Now, the final step of compiling this MSIL code into object code is done by using what's called a just-in-time compiler, and this would exist on the user's machine. So just like Java, the developer achieves portability across multiple platforms because the source code is compiled just once. It's compiled into the MSIL code. Now, there is one big difference between how Java handles this and how the .NET handles this. So with the Java bytecode translator, it's actually an interpreter, which means that a program is translated into bytecode and executed statement by statement. When the program is done, there is no object code that's retained. So the next time that we run this Java code, the interpreter would have to repeat looking at each line of the code and interpreting it. With the .NET approach, on the other hand, the code is actually compiled, not interpreted. So what that means is it's actually going to translate the MSIL code into an object code, and it's going to execute it. So then when the program is done executing, the object code still exists. So that way, whenever we need to run that program again, we don't need to recompile it. We can just take a look at the object code. So the difference here is that we get a more efficient program execution because we don't need to interpret it every single time we run the program. Now, last thing to note here is that there are over 60 programming languages that have been adapted to fit into the .NET framework. So just to give a couple of examples, Ada, Fortran, COBOL, C++, C#, of course, and Visual Basic. So all of these different languages and many more are being supported by .NET.